This is section 8.8. Listen up, guys. Section 8.8, and the title is called Difference of Two Squares. What does the word difference mean? Subtraction, right? So if I say, what's the difference between 7 and 5? The answer is 2, right? 7 take away 5 is 2. Difference means subtraction. It says, so the difference, the subtraction of two squares. Do we remember what squared terms look like? Perfect square terms?
4,
Yep.
9,
Yep.
16,
4, 9, 16, 25, and we know the rest, right? So if you have the difference and there are two perfect square terms, you're going to be able to apply this shortcut that I'm about to teach you. The shortcut is this. This is when they ask you to factor, by the way. When they ask you to factor, the shortcut is this. If you have a perfect square term and another perfect square term, and you are subtracting, you could square root the first one, square root the second one, and plug them into your factored form answer format. So what is the square root of 4x squared? 2x, right? So I'm going to put a 2x right here and a 2x right here. Now what's the square root of 9? 3. So I'm going to put a 3 right here and a 3 right there. That's from taking the square root of 9. Okay, now the question is, I do not have a trinomial, which means that if I were to start distributing, the middle terms would have to cancel out, and the only way that's going to happen is if one is a plus and one's a minus. You don't have to put a plus first, you can put a minus first and then a plus. As long as your signs are different, you're good. So I've just showed you yet another way of factoring, because before learning this method, you would look at the 4x squared and the minus 9. You're like, well, I can't pull out a GCF. 4 and 9 don't have anything in common. There are no x's in common. It's not a quadratic trinomial. This is a new form of factoring, right? And it's called difference of two squares. It has to specifically be when you're subtracting, and it has to be two perfect square terms. Square root it, put your answers there. Put those same answers here. One has to be a plus, one has to be a minus. Easy, right? That's it. Let me make some space here, and let's look at another example. Copy this one down, please. Could I apply this new method called difference of two squares factoring method on this?
Yes.
Yes. Why? Because we really do have a perfect square term here. I like to put a square around it just to emphasize that they're perfect square terms. We have a perfect square term here, and we are subtracting, which means difference. So yes, we could apply the difference of two squares shortcut here, or factoring method. So let's put our parentheses, and let's actually do the square root of 25x squared. Yeah, the square root of 25 is 5, and the square root of x squared is x. So we have a 5x on the first part of our binomial, a 5x on the first part of the other binomial. And now the other one, this 49y squared, when I square root it, the square root of 49 is 7, the square root of y squared is y. So I have a 7y right here and a 7y right there. And now I just plug in my two opposite signs. It doesn't have to be plus first. It could be a minus first and one plus, but they have to be opposites. Okay, one has to be a plus, one has to be a minus. Do we understand that? Actually, let me verify why one has to be positive and one has to be negative. Think about this. What's 5x times 5x? 25x squared. Okay, so far so good. What's 5x times 7y? 35xy, right? 35xy. And then what is negative 7 times 5x? Negative 35xy also. And then last but not least, negative 7y times positive 7y. That'll give you a negative 49y squared. I'm just showing you why it actually works. You see these middle values? They're both xy terms. What happens to them? They cancel out. So I just wanted to show you that they cancel out because you had opposite signs. If you would have had both plus, then these would have been both pluses. And they wouldn't cancel out. And you need the middle value to cancel out because it's only a binomial. That's why it's called difference of two squares, right? We will be dealing with perfect square quadratic trinomials in lesson 8.9, but right now 8.8 is just the difference of two squares. So again, they have to be perfect square terms, and there has to be a minus sign. Let's copy this one down. Let's do one more. I'm sorry. Let me get rid of that. Here we go. How about this guy, number 3? Could we do that one? No. Because a plus sign, right? Remember the title, difference of two squares. Do we have a difference here? No, it's a sum, right? So you can't apply the difference of two squares, right? So what would we do here? I would try to pull out a GCF. Is there something in common with the 9 and the 4? No. And you can't square root them, and you can't do the shortcut, because the only time you could do the difference of two squares is if it's actually a difference. And this is not a difference, it's not subtraction. So we're stuck. Is there anything to do? No, you can't. You can't factor. A perfect answer would be not factorable, right? But might as well write down what you're going to see on a multiple choice test and the final exam at the end of the year. I believe they write the word prime. Prime just means not factorable. Not factorable. And what does not factorable mean? It means that you're not able to factor. But they're going to use the word prime when you can't do anything. And it will come out on our worksheets, on our homework that we have today and also next week. Okay, so we were not able to do that one. You could not do difference of two squares because it wasn't a difference, it was plus. Let's check out this one right here. Copy that one down. Could I apply the difference of two squares? No. So what do? Do I just give up and say prime?
No.
GCF, that's right. Always start by pulling out the GCF. Even if you do have a perfect square term in the front and the second one's also perfect square, try to pull out a GCF first always. So when I look at the 8 and the 18 and the x and the x, what's in common? A 2 and an x. So what would be left over on the inside? A 4x squared, and then a minus 9. Now check this out, guys. We pulled out the GCF 2x. On the inside, that blue part is really a difference of two squares. So I could continue using the difference of two squares factoring method. So again, I have a perfect square term here and a perfect square term over here. So I'm going to set up my factor format. I'm going to do the square root of 4x squared. What's the square root of 4x squared? 2x. Put that right there. What is the square root of 9? That's 3, right? So you have a 2x and a 3. Repeat that 2x and that 3. And what do we know about these signs in the middle? They have to be different. So you could put plus minus, you could put minus plus, whatever you want, plus minus. Let's not forget about that outside 2x that you originally factored out, the GCF, the 2x, bring that down. And ladies and gentlemen, this is the complete factored form of the original cubic binomial. Okay? So again, we pulled out a GCF, and then we were able to do the difference of two squares. Okay? So it's pretty simple. Besides factoring, just like on all the other worksheets, we also have solving. Let's just jump to the worksheet right now. On the homework that you see here, we're going to be doing numbers 1 through 15. That's factoring, right? And we're going to be using different methods. Always try to pull out the GCF first. If you do have a difference of two squares, you could use the difference of two squares factoring method. And notice the second half, like all of our other worksheets, the top half is factoring, the second half is solving, and you actually have equations. So I want you to do all of them. I want to explain the odd ones here. So number 1, do we have a difference of two squares? Yes, it's difference, a minus sign. This is a perfect square term, that's a perfect square term. So if you wanted to use the difference of two squared method, let's do that, right? So what is the square root of k squared? It's just k, right? So just k. What is the square root of 100? 10. So you put the k there, you put the 10 there, and what about the signs in between? Positive and negative. One positive, one negative, or one negative, one positive. Doesn't matter as long as they're different. Now, did we have to use the difference of two squares method? No, not really. Since the a value is 1, you could have said, all right, I could do the old school shortcut, put a k right there and a k right there, and I would think what times what is 100, or actually what times what is negative 100, that if I combine together is my middle value, which is 0 because there is no middle value. Then you would say, oh, positive 10 times negative 10. That gives you negative 100, and if you add them together, it does give you 0. So you don't have to use the difference of 2 squared method, but you can use the difference of 2 squared method on number 1. Let's take a look at number 3. So do I have a difference of 2 squares? Yes or no? What should I do first, even before difference of 2 squared? GCF. Always do a GCF. Is there a GCF we could pull out? 4. If I pull out a 4, what would I have left on the inside? 4p squared minus 9. So now, if we look at the inside, we actually have the difference of 2 squares. So on the inside, because I have a perfect square term here, and because I have a perfect square term here, I could set up my difference of 2 squares factoring method. So I do the square root of 4p squared. What's that? 2p. And I do the square root of 9. What's that? 3. So I have 2p and 3, 2p and 3. What signs belong in between them? As long as they're different. 1 plus, 1 minus. What about that 4 that's out in the front? You just bring it down. That was the original GCF. Ladies and gentlemen, this is your answer. If you check the back of the worksheet, that's what you'll see. That's the factored form of it. Let's try number 5. Do we have a difference of 2 squares? Okay, so we do have a difference of 2 squares, but before beginning, always try to pull out a GCF. And with the calculator, you could see that you can pull out a 9. Now, if I divide 144 by 9 on the calculator, 16. So we have a 16 here. And then 9 times what gets us to a negative 9f squared? Well, that'll be a minus 1f squared, right? Or just minus f squared. So now on the inside, this black binomial is a difference of 2 squares again. So I am going to do the difference of 2 squares. So this first perfect square term, when I square root it, what do I get?
4.
4. And how about this second f squared? When I square root it, what do I get? F. So I really have a 4 and an f, and we need to put opposite signs, 1 plus, 1 minus. What about that 9? Bring it down. We are done. It's very important that you pull out that GCF. If you don't pull out that GCF, you're going to end up with the wrong answer. And, that hardly ever happens to me, but yeah, I'm just, it happens a lot. Okay, so do we get the hang of the first half?
Yes.
Now the second half, let's take a look at the second half. This is an equation. There's many ways of doing it, right? Because it's an equation, you can do whatever you want to each side as long as you do it to both sides. So let's subtract 81 to get it equal to 0. Subtract 81. You're going to end up with 4y squared minus 81 equals 0. And on this factoring chapter, it's great to have something equal to 0, because if you could factor and it's equal to 0, you could use the zero product property to split it and solve. So let's pull out a GCF. What could I pull out of there? Is there a GCF? No. Okay, so do I have a difference of 2 squares? Yes, I have a difference of 2 squares. Here's a perfect square term, and here's a perfect square term. So let's use our difference of 2 squares factoring method to rewrite it as what? What's the square root of 4y squared? 2y. Actually, let me do this in red. Sorry, 2y. And what's the square root of 81? 9. What signs belong between them? 1 plus, 1 minus. Ladies and gentlemen, we're almost done. All we have to do is split the equation to create 2 simpler equations. So the 2y plus 9, that could be 0. And the 2y minus 9, that could also be 0. So if I solve one by subtracting 9, I'll get 2y equals negative 9. And if I divide by 2 and divide by 2, y equals negative 9 halves. That's one answer. The other one, same thing, plus 9. We're going to end up with 2y equals 9. We are going to divide by 2, and y equals 9 over 2. So you get both a positive 9 over 2 and a negative 9 over 2. So that's all we're doing on the second half. We're still applying the difference of 2 squares wherever we can. And that's about it. So is there any other one you would like to see?
Putting
22. A lot of people get freaked out with that fraction, huh? Now remember, an equation, yeah, it's equal to 0, that's great. But an equation, you can do whatever you want to an equation. So if you don't like that fraction, you could get rid of the fraction by multiplying everything by that denominator, 36. So imagine that, times 36, times 36, times 36. So I'm going to need some help here. Get a calculator. The 36 cancels. I have a nice, beautiful x squared minus, what's 25 times 36? It's going to be huge. 900. Okay, equals 36 times 0 is still 0. So do I have a perfect square term here and here? Yes, I do, right? It's a difference of two squares. So I could actually use the difference of two squares factoring method. And what is the square root of x squared? That's just x. Now, what is the square root? What is the, oh man, hold on a second. So the square root of x squared is x. And the square root of 900 is 30. So x and 30. And one's plus and one's minus. So when you split them and you get x plus 30 equals 0, and you get x minus 30 equals 0, you're going to get your two answers, x equals negative 30 and x equals positive 30. By the way, sometimes they write those answers like this, x equals plus or minus 30. They can put a little plus or minus symbol in front. That way it takes up less space. But that's how you do the second half, guys. So I hope this clears up what we're doing today.